Hey everyone, welcome back to My Codes. In this video series, we are going to talk about a bank dataset containing several transaction files and some other details to perform data science around it. Okay, so this is a basic data analysis dataset, but you can also perform fraud detection system around it. You can also make some customer segmentation project around it. You can also make some business intelligence project around it, and the list goes on and on and on and on. So the first thing that we do is we try to understand what this data set is. But before that, let me give you a quick update, or I would say overview about this series. In this video series, we are going to not only just cover up the basic data analysis, but we are going to perform all kinds of future projects that we can make, as I have told you right now, some of the projects. So we'll make sure that we cover up all that part with this dataset. And I'm also thinking to add some updated topics around AI, like AI agents, and some topics like RAG or maybe something else. I don't know, but we'll definitely figure it out, and we'll try to use all that. I'll probably make a BI project as well around this. I'll probably use Tableau, or if Power BI, then that goes as well. So yeah, that's pretty much it for the general overview about the series, and let's just hope that it goes well. So with that note, let's start today's session by first understanding our two important files of this dataset. But before that, let's look at our dataset.
So now let's talk about our data set. Over here we have financial transactions dataset analytics. Okay. So this is basically a dataset containing several CSV as well as JSON file. So we start by looking at our transaction data. Over here it's a CSV file which contains amounts, timestamp along with the merchant details. So just like any other transaction file where we have client ID along with the recipient ID as well as time, date, location and other parameters like this. This file is 1.2 gigabytes, so it's going to be a very large file to work with. Now, apart from this, over here we have a card information file which contains the information about card that we have, like CVV number, card number, along with other details related to the card. Along with that, we have this merchant category codes which contains category codes for different businesses. Okay, and then we have fraud labels which shows whether a transaction is a fraud transaction or it's not a fraud transaction. After that, we have a user's data, which is again a CSV file containing over 2000 values. That means this dataset is going to have 2000 unique users. Okay, and this is again going to contain data about users that we have. And the applications of this dataset can be a fraud detection system, or a customer analytics system, or a financial planning and forecasting system, or a business intelligence, or a machine learning project. To be honest with you, this is a complete data set where you can apply different concepts, whether it's about machine learning, deep learning, or in general data science. Okay, so this is a very huge data set that was given by C Axios Bank. Sorry if I mispronounce it. It doesn't matter. So after that, let's look at some of our CSV files over here. So in today's session, we are going to focus on two files, which is our user data file and cards data file. So our cards data file, as you can see, it's a CSV file, that is comma separated value file, and this file is going to contain ID. So this ID is basically the ID for this card. Along with that, we have client ID. Client ID is basically my user ID, and then we have the brand of the card, which is Visa, MasterCard, or any other brand that the user is using. Along with that, we have card type. So this can be either credit card or a debit card or a debit prepaid card. So over here we have three categories in card type. Along with that, we have a card number, expiry date, we have CVV, we have hash chip or not. So we are also going to check whether a card is going to have a chip or not. And that is shown by this variable, that is hash chip. Along with that, we have number of cards issued. So that this means if there is a card given to the user and that card was expired, so new card was issued. So how many number of cards are issued? So we can see over here that there are two cards over here. That means one card was expired, and so as the new card was issued to the same customer, okay, with the same card number. And this list is going to contain all those values. And in the end, we have this credit limit that shows the maximum credit limit that the user can access for this particular card. Okay, now let's talk about user data. This is again a very normal file containing information about our users that we have. In total, we are going to have 2000 values in this CSV file. That means we have 2000 unique users in our data set. Over here we can see we have id, which is referenced as a foreign key in our cards dataset, as this is a client id over here. So just keep this small thing in your mind. And after that we have current age of the user, then we have retirement age, we have birth year, birth month, gender of the user, and then we have address, latitude, longitude, and per capita income. So this is again a very short file containing different parameters, although these are not all the parameters, so we have to select all the variables over here, all the columns of the data to see other things as well. So per capita income, then we have yearly income. So per capita income is basically the average income of that particular town where the user is living. So we can see over here it is 29,278. So this is going to be per capita income for this particular location only. So over here, although we don't see this location again, but in our data set we'll surely see this location again. Okay. So after that, we have yearly income, we have total debt that the user is having, and we have the credit score and the number of cards, which is going to be similar to the number of cards that we saw before. Okay, so this is number of credit cards. So this is basically like how many cards are assigned to the users. So there can be a case where user is using more than one card. So this is just that reference number, and we can even cross check this by going to the cards dataset and looking for the client ID and count whether the client is having the exact number of cards as mentioned in our users dataset. Okay, so yeah, that was about our dataset. Now let's start exploring our cards dataset.csv file along with the users data.csv file. So over here we are in our VS Code, and we have made a directory as finance, which is going to be my directory to work with. In this we have two folders, data as well as statistical analysis. So in the data folder we have all the CSV and JSON file required for this project. For this video we are going to focus on cards data.csv along with users data.csv. In users data, we can see we have ID, current age of the user, retirement age, birth year, birth month, gender, address, which is going to be the address of our user, latitude and longitude value of the address again. We have per capita income. Now over here, per capita income means average income of the place where the user is living. So suppose user is living in an area, over here it's let's say 462 Rose Lane. So what's the average income of people living in this area will be my per capita income, and yearly income will be the income of the user, as well as total debt will be the debt of the user, and then we have credit score of the user along with number of cards issued to the user. Okay, so it's a pretty simple CSV file containing details around the user that we have, and this file is going to have 2000 values. That means we have 2000 unique users. After that, we have another table as cards data.csv. This is going to contain a unique ID along with client ID. Now over here, the client ID is basically my ID from the users data.csv file. Now this ID over here will work as a foreign key for this as a client ID in this cards.csv file. That means this file is going to get referenced to our users data.csv file by this client ID. Okay, so if you don't know about what's the reference key, what's the foreign key, what's primary key, so just check out the basic SQL videos and you will understand what it is. For now, what I can tell you is the fact that this is our row, and to uniquely identify this row out of all other rows, we have a unique number, and that unique number is my primary key. So over here, my ID is going to be my primary key. This ID is not going to be repeated for any other row in this table. Okay, so this will uniquely define my user. Similarly, if I want to take reference of this ID to any other ID, as you can see over here, its client ID is 825. So this will work as a foreign key, which will give a reference to any other table. Okay, so if you still don't know what's foreign key and primary key, again I insist you to please check out a video around SQL and understand the basics of these concepts. Okay, so after looking through the dataset, we can see over here also we have client ID, we have card brand, which is going to be my Visa, Master, or any other card brand taken by the user. We have card type, which is going to be debit, credit, or debit prepaid card. Okay, then we have card number when it is going to expire, and then we have CVV number, and then we have hash chip or not, whether a card is going to have a chip or not. Then we have number of card issued, and this number of cards issued is like when a card is expired, the bank issues a new card. So how many new cards are offered to the user? So this variable refers to that. Okay, then we have credit limit, which is going to be the limit for the user for that particular card only. Okay, and then we have account opening date, which is again a very important variable of our interest. We have year pin changed last. Okay, so when was the pin changed for the last? And then we have credit card on dark web. This is an interesting variable because you will figure out in few seconds. Okay, so you can already see there is only no values, there is no yes value, but still let's talk about the first file of today's session, which is going to be my users dataset. Okay, so I open this statistical analysis and I've already created this users data.ipynb, which is just a Jupyter notebook to work with in Python. Over here for this particular video, earlier on I thought to use pandas, but again pandas is not as faster as polars. So just to be quick and fast for this project, we are going to use polars. Although pandas is a better way to work around because there is a lot of online source to learn that, but still I insist you to learn something new, and so we are using polars over here. So if I import polars as ps and also the matplotlib for the graph purpose, so if I try to run this, either I can run this manually like this, or I can simply just do control enter. So this is the first option to click this button over here, and the second option is control plus enter to run the cell. So this is going to be my one cell that I've run, and I want my data to be over here converted as data frame. So this is a CSV file, that is users.csv, which is stored in data folder as we can see. Okay, so to get this file, we are going to first get out of the current directory by doing this dot dot slash, and then we are going to go to data directory. In that we are going to fetch this users data.csv file. So if I run this, I will be having my dataset in the form of data frame stored in df users. So to look at my file, I'm going to do df users.head. So dot head will give me the first five elements of my first five rows of my dataset. Okay. So you can see over here we have ID as 825, we have current age as 53. Now this is a very important variable, and if you already figured out, that's really great. If not, I will tell you very soon. This is retirement age, this is birth year, birth month. Again, this is gender. Then we have address over here, we have latitude, longitude values, we have per capita income, we have yearly income, we have total debt, which is again a very big number over here. And then we have credit score, we have number of cards issued. Again, this is 5, which shows a pretty big number to me. Okay, so now the question comes, what's wrong with this dataset when you try to look at it for the first time? Well, over here I can clearly see the current age is wrong. Well, if you look at the birth year, it's 1966. And let me just create a new cell over here by clicking on this code button. And if I try to print the age by basically just doing 2024, let's say, minus and the year, birth year of the user, which is 1966, you can see I'm getting 58. Okay, and over here it is 53. That means current age is not updated, which is really a bad thing for our data, for our calculations. But just for the sake of simplicity, for this video only, I'm going to consider it as the current age only. But yes, again, in the future episodes, we are going to change these values and work around accordingly. But just for this video, as I just want to teach you guys about these two files, I'm not going to focus on this for now. But in future, we'll definitely change it. Okay. So let me just erase this cell. And now what I want to do is I want to add a new column, that is retirement status. Because we have retirement age, so we can check whether a user is already retired or not. How can we do that? We can subtract the retirement age with the current age of the user. Although it is not updated right now, but as I have told you, for the sake of simplicity, we will follow this order only. So if I check it like this, if my 66 is greater than the current age, that means user is not retired. And if this number is not greater than the current age, that means user is retired. So as you can see over here, current age is 81 and the retirement age is 67. That means user is retired. Okay, so that's a way to check whether a user is retired or not. Okay, so I have written the logic over here. Now again, in polars it's pretty difficult to work, but not that difficult as well. So you can see we have df users dot with columns, and over here we are using ps dot when, ps dot column, and over here our column is current age. So you can see over here we have current age. If this is greater than ps dot column, and then in this column we are basically passing the retirement age. So if this value is greater than this value, then we are going to basically add a literal. Now this is a literal, lit means literal. Okay, so we are going to add a literal retired, otherwise we are going to add a literal not required. and then we are going to alias. That means we are going to add a new column. If I don't want to add a new column, I can just simply change the existing column as well by putting the same name over here. But that is not something that we want to do. We want to create a new column. So over here, I'm passing the name of the new column as retirement status. And then we are checking whether the dataset or data frame is updated or not. As soon as I run this code, you can see we have a new column over here that is retirement status, which is something that we wanted. It is over here as not retired, but for the third case, it is retired. So let me check the value for the third case. And yes, it has to be retired because the current age is greater than the retirement age. Okay. So after that, we are going to describe our data frame to check about the variables. So this will tell us the mean value, the standard deviation, along with the maximum, minimum, and other values like that. Okay. So you can see the total count over here is 2000. That means we have 2000 values, and there are no null values since all values are 2000 over here. Okay. There is no value less than 2000. After that, we have null count as 0. That shows that we don't have any null values in our data set. Then we have the mean value for, let's say, current age is 45. That means the mean average value, average age of our users is 45, around 45. And then we have retirement age is that, which is around 66 for the users. Birth year is around 1973, and the birth month is around June. So maximum people in our dataset were born around the month of June. And just other things like this. We have minimum values as 18. We have maximum values as, you can see over here, 79. And you can just check on this whole list of description about our dataset to just get a better idea about what our dataset is and how the values of our dataset are working. Okay. So for now, I want to also check the unique values for categorical variable. So categorical variable means any variable that is going to have a categories as its output. So you can see over here, we have, let's say, this address as a categorical variable because we have multiple values. Now, although this is not a categorical variable because we are going to have a lot of different addresses, still I consider it as categorical variable. Over here, gender is also a categorical variable because it is going to have male, female, or not preferred. Okay. Then we have this retirement status as a categorical variable as well. So for this video, this is going to give categories as all variables that are a part of string. But in the next video, we'll make sure that we convert this string into integer as well so that we don't get this kind of errors. Okay. Although it's not an error, still we don't want it. So over here you can see gender is going to have 2 unique values. Address is going to have 199 unique values. That means 2 people are going to have same address. And yes, that's it. Then we have per capita income, yearly income, and again we have retirement status as 2 unique values. And we also want to check whether we have any. So first I run this code and you can see we are getting the same output. And then we will check for the duplicates in our data set. So by doing is duplicate, we can check for the duplicates and then we can sum those duplicates. And you can see we are having 0 duplicates. And we already saw this before in this dot describe method with our data frame. Okay. So you can see we have null counts as 0 for all cases. And duplicates will check whether we have 2 similar rows or not. Okay. I'm really sorry for the disturbance. Let me just turn it off. Okay. And now we have this histograms to know about the spread of our dataset. So let's talk about histogram by taking just a 1 second break.
So let's see these two graph. When you first look at this graph, you can find some sort of non-similarities because the first graph is leaned more towards the right, whereas the second one is leaned more towards the left. So this is what we have to study. If the graph is more towards the right, we'll call it as right skewed. And if it is more towards the left, we'll call it as left skewed. Well, we'll understand the use of these graphs later on. For now, just understand what you call this graph. So the first graph will be my right skewed and the second graph will be my left skewed. Now let's take a look at these two graphs as well. Over here, the first graph looks like U, so I will call it as U-shaped. Second is like a bell, so I will call it as bell-shaped. Now look at this graph over here. The first one is a graph, second one is also a graph, and third one is also a graph. Now when you look at this graph, you can see in the first graph we have one peak, which is the highest value. But in case of second graph, we have 2 peaks. In case of third, we have multiple peaks, or over here you can see 3 peaks. So the first graph will be unimodal, second one will be bimodal, and the third one will be multimodal. Now guys, again, right now I can't explain the proper use of this. So just keep these terms in your mind. Definitely we are going to use all these terms in order to define our data that we get. So for now, let's just say we learned about skewness, left skewed, right skewed, and then about U-shaped and bell-shaped graph, and now unimodal, bimodal, and multimodal. Now let's talk about a very important concept known as interquartile range. Now this is going to be the one of the only, I would say, concept that you need to understand in order to master the descriptive learning. So what is interquartile range, or I would say IQR? Well, the definition says IQR is Q3 minus Q1. But what is Q3 and what is Q1? Let's take a look at this graph over here. Here I have a x-axis, which is increasing, of course, and I have this random graph that shows the distribution of my variables with respect to x. So I can see the graph is normally distributed because the graph is equally divided to both left and right side. So when you look at this graph, this is not even left skewed or right skewed. This is a bell-shaped graph, and yeah, that's all for now. Now let's try to see what is my Q1 and Q3 in this graph. Well, let's create this line over here, and all values that fall before this line will be 25% of my total data. And when I create one more line over here, all values that fall before this line will be 75% of my total data. Well, if I mark this part of the graph, you can see this will be the points that will cover up 25% of my total data set. So this will be my Q1, and Q1 is 25% of my data set. Whereas if I cover up this part over here, it will be Q3, and this will cover 75% of my data set. And in between, I have something that is known as Q2, which will be Q3 minus, which will be the center point of Q3 and Q1. Okay, so Q2 is like 50%. Okay, so anything before Q2 will be going to be 50% of our data set. Now let's see what this graph has to offer us. If you look in between, we have something that is between Q3 and Q1, and this something between Q3 and Q1 is our area of interest, because we call this as interquartile range or IQR. Now this IQR or interquartile range is equals to Q3 minus Q1. So this part over here, as you can see the shaded region will be my region of interest, or I would say IQR, interquartile range. So there are total 5 variables that we have to consider. First one is minimum, second one is maximum value of our dataset, and then there is Q3, Q1 and interquartile range, which is IQR. Okay, so that is Q3 minus Q1. Now let's take the example of age of students in a class. Suppose we have a class with minimum age of 9, maximum age of 53, and then we have first 25 percentile as Q1 is equals to 19. So 25% students fall, like in this data set, falls under the age of 19, whereas 45% of the students fall under the age of 25. So in a class, I have students with a maximum age of 53 and the minimum age of 9. But 25% of the students are below 19 and 75% of the students are below 25. So now you got what we are going towards. Okay, if not, then let's look at what is IQR. So here IQR will be Q3 minus Q1. So Q3 is going to be my 25 and Q1 is 19. So my interquartile range will be 6. So if I try to calculate the median, it is going to be 6 by 2, which is equals to 3. Now this median and this interquartile range are really important for understanding the descriptive analysis for this variable. But for now, let's just see what we can do with these variables that we got till now, or why we are doing these calculations. Well, if you look at this graph carefully, or I would say this values carefully, first 25% of the data will be under the age of 19. Means in my class, if I want to calculate something, the first 25% data points are under the age of 19. Whereas 75% of the data of the students are under the age of 25. So here the maximum age is 53, but 75% of the students are under the age of 25. Okay, so mark these points, and with these points, let's talk about what is outlier. Outlier is an extreme observation, a value far from the most others in a set of data. Over here, we can see that there are 2 formulas to define what is an outlier. If observation is less than Q1 minus 1.5 times IQR, or if it is greater than Q3 plus 1.5 times of IQR. Now, you can visualize this in your mind if you know what we have studied previously in the last slide, but if you can't, let me just show you this example again. So here, we know that age of students, IQR, everything is given to us. So with this, let's try to calculate an outlier. Okay, so what will be my outlier? So looking at the first definition, it says that it should be greater than this value. So Q3 plus 1.5 times of IQR will be 25, as my Q3 is 25. And then I'm going to say plus 1.5 into 6. So this gives me a value of 34. So any data point that is greater than 34 will be my outlier. Now what is outlier and what is the problem with outlier? Well guys, in our data set, when we have maximum values around a particular point, and if there is something outside that value, that will just skew my data set. And so because of that, I will not get a normally distributed graph. So outliers will change my mean, my median, and all of my other values like standard deviation, which will not give me the results I am looking for. I know that you are not able to predict, or I would say depict what I'm trying to say in your mind. But for now, let's just see. So let's just see this example over here. We got the maximum value like that from which you can't go more than that, which is 34. So if there is a point or a data point in my data set which is greater than 34, will be considered as an outlier. Now let's take another example, another rule, which is if your data set, if your data point is less than Q1 minus 1.5 times of IQR. Now you can see where the data set is greater than Q3 plus. So here we are checking anything that is outside Q3 plus 1.5 times of IQR. But in case of Q1, we have to just take a look at anything that is before Q1. So Q1 minus 1.5 times of IQR. So if anything that is less than 10, if you calculate this, 19 minus 1.5 into 6, if anything is less than 10 or my age is less than 10, then that will be considered as an outlier. Okay. So with this knowledge that you got till now, tell me whether this 9 is an outlier or not. Well, if I look at the first condition, it should be greater than 35, but 9 is not greater than 35. So it's not an outlier. But wait guys, you also have to check the second condition, which is it has to be less than 10. It has to be less than 10 in order to be an outlier. So here it is less than 10. 9 is indeed less than 10. So it is going to be an outlier for this data set. So if any student is having an age of 9, will be considered as an outlier.
So, welcome back to histograms. Well, histograms are used to find out the spread of our variables or our columns that we are working with. Okay, it is used for numerical values. And in order to fetch numerical values from our data frame or from our data set in general, we have to do something. So, in the first step, I have created a list over here as int columns that is going to have all columns having integer values. And I'm going to use df users, which is my data frame, and I will select ts.columns that is integer, and then I'm going to just say dot columns. This is a way to fetch all the columns that are of type integer. After that, I'm going to say number of plots, which is a variable which will be equal to the length of our integer columns, because we want to know how many plots we want to make, and in order to do that we have to find out the number of integer columns. So that's the way to do it. Basically over here, length will calculate the length of our list, which is over here int columns. Okay, after that we are just creating a plot over here with a row as 1 and columns as number of plots. Now I want all the plots to be in a same row. You can tweak these values and you will get your results accordingly. But for the sake of this video and simplicity as well, I'm going to print out all the columns, or I mean all the plots in one single row. And this will be the size of the figure. Again, it's a tuple value having the size as height and width. Okay. After that, what if we only have one plot? Okay. There can be a case where our data set is only going to have a single numerical value. For this case, we are going to convert our access, which is a list, to a single variable. Okay. And after that, we are just going to create a histogram, just like as we do in Matplotlib. This is nothing new, I guess. And after that, we are going to set it as tight layout and we'll show our histogram. So as soon as I press Control Enter, or you can do it manually by clicking over here. So after doing it, we can see we got our beautiful histogram over here. So in order to check it, I'm going to click on this middle button, expand image. After clicking on it, we can see we have this histogram ID over here. Let me just cut it off. And okay, so this is our histogram ID, and this is again not something of our use. Something of our use is current age. So we can see almost 140 or more than that people are having their age around 20, and then this graph is going like this. So we can see a lot of people are having lesser age than people having more age. So this graph is somewhat uh, right skewed. That means more values are towards the right than towards the left. Okay, so this is a type of graph that we can easily check by looking at where are the extra values. Okay, so we can see there are more values towards the right, so we call it right skewed histogram. Although this is not something really advanced, still important to know. After that, we have retirement age over here. And if I look at retirement age, I can easily see that retirement age is having somewhat values around 65 to 70. Okay, so this is actually not normally distributed. That means it is not a complete normally distributed graph. Still, you can see most of the retirement ages are around 65 to 70. Okay, after that, we have our birth year over here, which is you can see more birth years are around 2000. That means in our data set, users are more around this age of are born in the year of 1960 to 2000. Okay, so there are very few users that are having their ages around 19 who born in the year of 1940 or before that. Okay, so this is also a very useful information for us that shows that people born before 1950s were less likely to create our account in our bank. Okay, so again, a very normal information, not a great thing to know, still we are figuring it out. And then we have birth months. We can see more people are there in the birth months of 2 and then 11 and 12. That means more people were born in February and in the month of uh, November and December as well. Okay, so again, a normal information just to keep in your mind. And then we have this histogram of retirement age. Again, it is between 65 to 70. Oh, I again came back. So we have this over here as credit score. So a lot of people are having their credit score between 700 and 750, and a very few people are then having their credit score between 800 to 850, which is again something important to know. And this graph also shows that majority of people are having their credit scores between 700 and 750, and a very few people are having their credit scores below that. Okay, after that again we are having another important variable, which is number of cards. Although this is not that important, still we will try to look at it. So over here we can see there are a lot of people having more than 3 cards, and there are very few people having their cards more than 6 or more than 5. Okay, so that's how you use histogram to know about your data set, and we did it pretty much in that way only. Okay, so after getting this insights about your user data set, we can also use box plots in order to find the same thing, that is the range of our values. Okay, so box plot tells us about where is our majority of the data set lies, where the majority of our users and our values lies. Okay, so over here again, in the same way as we did before, we are going to create a box plot instead of histogram. Okay, and the rest of the code is almost the same, so you don't have to worry about it. If I do control enter over here, you can see I'm going to get a histogram this time. Now let me teach you how to read histogram. So these two values over here shows the area of our interest. It is also known as IQR, that is interquartile range. And in between we have the middle value. So for this ID, again this is not something that we worry about because ID is just a random value. So let's talk about age. So we can see in the box plot, we are having the age median value as 40, and our area of interest is going to be between 60 to somewhat around 30. And the age, there is also a bubble over here that shows the outlier. Well, outlier is the value that is really something different from all other values that we have in our data set. So we can see there is a value that is above 100. So there is a user existing in our data set having their age above 100. So this will be the outlier for our case. In general, the way to find outlier is shown right now on your screen right now. Okay, so that's a way to check whether a given point is an outlier for our data or not. Okay, so using that we can do it. If you want to know more about outliers, you can check out the link in the description where I have taught you about general things related to interquartile range and also about this concept of outliers. Okay, so what I'm thinking is I'm going to add that video to this only so that you can understand all these concepts before you think more about outliers and box plots. Okay, so it will be beneficial for you. Now after that, we can see the retirement age is between, sorry, you can see the retirement age over here. I hope you can see it. Yeah, it's between 65 to somewhat around 67 or 68. And there are a lot of outliers we can see in this case, but the median value is still around 65. And we can see the same thing in our histogram as well. If I open my histogram and if I check for retirement age, you can clearly see there are more values between 65 to 70 and very few values before, let's say, 55 or 60, and after 75 or after 72 or 73. Okay, that shows that these values can be potential outliers, and we can also see the same over here. After 72, we are having a lot of outliers, and the same for before 60 as well. Okay, so yeah, that's another variable of our interest. Similarly, for birth year, we have most of the people born between 1960 to 1980. The same thing we also saw in our histogram. You can see the more people are born after 1960 to 2000, and a very few people are born before that. And the similar thing is shown over here as well. There is a maximum value of 2000 and minimum of 1920, and there are some outliers over here as well. Okay, and you can do the same thing for all other graph. Your task is to do it by yourself. Over here I'm going to just show you these three which are left. I'm really sorry. I think that was a bad idea to get a row for all the plots, because now I'm not able to work around it. Again, sorry for the inconvenience. You can see over here we have birth month, which is again a normal thing to check out for. We have credit score, and you can see there are a lot of outliers having their credit scores below 600. Okay. Similarly, card numbers, there are a lot of outliers having their card numbers more than 7. Okay. So yeah, that is it for our users data. This was some general information that we tried to fetch from our users data.csv file. Although there are a lot of other things to get, and we are going to do that pretty soon. But for now, for this video, this is pretty much it for the users data. Now let's talk about our cards data.csv file. So now let's talk about our cards data file. Over here you can see this is going to be my CSV file having multiple variables. So let me just quickly open up this cards data.ipynb, which is going to be my Jupyter notebook in this case. And over here also we are going to use polars for our analysis instead of using pandas, because it's much faster than pandas. We have our matplotlib, and then we have our numpy. So I'm going to import all this libraries over here. If you get an error while doing this code, it's probably because you have not installed these libraries in your computer. So the way you do it is by opening up a new cell. This is known as a code cell over here, and then you just have to type pip install and the library name, which is going to be polars, or it can be numpy, or it can be matplotlib. Okay, so you type in the name of the library and you will get it over here. So for now we already installed, so we don't want to install. The other way to install is using terminal. You go to the terminal and you simply just type pip install and the name of the library, which is polars in this case. Press enter and it will be installed. Simple as that. So after that, if you try to run this code cell again by pressing Ctrl plus enter, it will run. Okay. After that, we are going to fetch our CSV file and create a data frame as df cards. After you do it, you get your data frame. To check the first 5 rows, we have dot head function. So we're going to execute it, and you can see we are getting this id, client id, which is my foreign key as discussed before. Then we have card brand, which is going to be Visa, MasterCard, and there are 2 other types as well that we will figure out in the future. And then we have card type, which is going to be debit, credit, and debit prepaid. Then we have card number, expiry date, along with CVV number. You can also see we have the type of the column over here, which is string in the case of hash chip. Hash chip is going to have 2 values, whether a card is going to have a chip, that is yes, or whether the card does not have a chip, that is no. Okay, so it's of type string over here. And I64 shows the integer type, whereas F64 will show the floating type. Then we have number of cards, which is again an integer type column. We have credit limit, which is sadly a string type, but we will convert it to integer type for the sake of simplicity to our analysis purpose. Account open date is also of a string type. It has to be of date month type, kind of like date format, but it is of string format. So we have to convert this as well. Then we have year last pin changed, and then we have this card on dark web. So this is again a string type having 2 values, yes and no. So now the first thing that I want to do is I want to remove this type of string and convert it to numeric type. So in order to do that, what I'm going to do is I'm going to say df cards equal to df cards dot with column, and I'm going to fetch this column by typing this line over here, that is ps dot column, and I'm going to pass the name of the column, which is credit limit in my case, and then I'm going to replace this string with basically nothing. As you can see over here, anything like dollar or comma will be replaced by nothing, that is blank. And literal false means I don't want it to be a literal type, so I'm going to put it as false over here. After that, I will cast it to a floating type number. Okay, so it's a pretty simple way to write the code. If you are not able to understand, simply put this code on any LLM model like ChatGPT or Grok or Claude's, maybe anything else. If you have it, just type it over there and try to understand this code in a much better way over there. Okay, so use LLM when it's needed. Although it's pretty simple to understand, all you need to do now is press Control Enter to run this code cell. After that, for our date as well, we have this account open date over here, and this is in the format of a string, but I want it in the format of a date. So to do it, I'm simply going to say that str timestamp ps.date and format will be set as month year. Okay. After that, I'm gonna alias this converted string into the existing column only. So the column will be updated and the new values will be of type date. Okay. So if I run this code, and now if I try to fetch the first five values of our data frame, you can see over here we are getting our credit limit in the format of floating numbers, and we are getting our account open date in the format of date. So that is what we wanted to achieve, and we got it. So look at this code. If you are able to understand, it's perfectly fine. If not, try to copy this code and search on online platforms, preferably any LLM model, because it's much easier over there to understand. All you need to do is just copy this code from GitHub. The link will be in the description, and paste it to the LLM model, and just simply write that explain me what is going on in this line of code, and it will do the work. Okay. After that, do the same thing for this code cell if you're not able to understand, and if so, then you can see this is our output. And now let's try to see what else we can do. Now there are a lot of categorical variable over here like hash chip, which has two values, yes or no. Similarly, we have cards on dark web, which is going to have again two values. So to check for categories like card names and card type, to know how many unique values are there, I'm going to use this code cell over here, where I'm getting a list of columns that are of type strings. And the way to do that is by saying dfcards.select. And what I'm going to select is ps.selectors will select only the strings. Now, instead of strings, I can also select the integer values, which we have already seen previously in our users data.ipynb file. For now, we are going to select strings, and then we are going to iterate through the strings and get those unique values. So you can see over here we have four types of card brand, we have three types of card type, we have this is completely useless. Then we have two types of hash chip values, that is yes and no. Similarly, for card on dark web, we have one value. Wait a minute, I think cards on dark web should have two values. If there is only one value, that means there is no card which is available on dark web. Okay. So in order to get this thing, what I want to do is I will do a filter search over here to filter out all the rows having this particular column value as yes. Okay. So if I try to run this code, you can see there is no such row. Means in our dataset, we don't have any value where the cards on dark web is yes. That means this column is kind of constant. All values are no. And when you get such columns, it is basically useless for you to take that column for the further analysis. And in order to drop that column, we have a drop in place function in polars. So using that drop in place function, as you can see over here, I'm going to drop this column. So as soon as I press Control Enter, this column will be dropped. And to check whether this column is dropped, again I'm going to say df cards dot head to get the first five rows. And you can see in this first five rows over here, I have year pin changed last as my last column, and the column which was after it is now deleted, or I can say dropped. Okay. After that, now let's talk about the graphical analysis by first taking a short amount of break. Well, now let's start with the graphical analysis. And graphical analysis is really important to understand the relationships between different columns, to understand the effect of different variables. Well, we'll start our analysis with card brands to see the distribution of different card brands across the number of cards that we have. Okay, so over here we have a subtype as well, which will show which type of card it is. Suppose I have a card of type of brand Visa, which is of type credit. So I will say that I have a credit card of Visa. Also, I can have a debit card of MasterCard. I can have a debit prepaid card of MasterCard. So to check on this distribution of cards in our card brands and then the subgroup of card type, we have to make a histogram over here. Now in this code, before I explain you what's going on, let's quickly look to our beautiful graph over here that says distribution of card brands by type. Over here we have MX card having only 402 as the total number of cards distributed, and all of these cards are in this blue color, which states that it is of type credit. That means in the market right now there are 402 MX cards and all are of type credit. Okay, similarly for Discover brand we have 209 cards and all are of type credit. For MasterCard, we have 383 users having debit prepaid card, we have 2191 users having debit card, and we have 635 users having credit card. For Visa, we have 811 users having a credit card, 1320 users having debit card, and only 195 users having their debit prepaid card. Now looking to the code, although I'm not going to able to explain you each line of code due to the time constraint that we have, if I try to explain it to you, it will probably take me 5 hours just to make this video, and that is what not something I want, or I hope that you also don't want it. So wherever you get stuck, you can read this comments over here to understand what that line of code is going to do. And even if you are not able to understand that part, you can just copy the code. I will definitely provide the link in the description, and you can paste that code to any LLM model like ChatGPT or OpenAI or maybe Claude if you want to use. Like OpenAI is any other model, or Gemini or anything like where you feel comfortable with, and you can simply just write explain me this code step by step. Okay. So over here, I'm just going to explain you very quickly. We are going to have card counts, and we are going to count the cards into group by card brands and card type. And after that we are going to create a list of brand labels and brand types. Okay, type labels. So this will be a list containing three types of cards that we have, which is going to be my credit, debit, and debit prepaid. For brand labels we are going to have four values: MX, Discover, Mastercard, as well as Visa card. Okay, and after that we are creating a dictionary that will store the count of card brand and card type. Okay, so it will be a tuple as a key, and to this key the value will be my count of the number of cards having these two factors. Okay, so and then the rest of the code is similarly like this only. Over here we are updating the counts, and then we are converting this to a matrix, and after that we are just setting out the pairs to get the colors for different card types, and then we are making the plot over here, and you can see how we are assigning each and every value. Over here we are setting X label as card brand, and then Y label as count, and then the title is distribution of card brands by type, and you can see the title over here as well. After that we are setting up the settings for our graph, and then we are just doing plt.show to show our graph. Okay, so again, as I've told you, if you are not able to understand the lines of code, simply Google it out. Although it's pretty simple, if you read out the comments it will be really easier for you to understand what's going on, but still that's just a suggestion from my side that you can follow to get a better insight. Okay, after that we have a bar chart over here which shows the type of cards and their distribution. Okay, so over here also we are going to count it out, and then we are going to follow up the following instructions to create a bar chart for it. Okay, so you can see we have three types of card: debit, credit, and debit prepaid. Debit cards are having more number of distributions, that is equal to 3511. So out of our total cards that we have in the dataset, almost 3511 cards are of debit type, only 2057 cards are of credit type, and then only 578 cards are of debit prepaid type, which is again a really important information to keep in mind. After that we have pie chart, which we create with .py, and later on you can check out all these things by yourself. Comments are there so that it will be easier for you to understand what's going in that line of code. So this pie chart will show the distribution of our card brands across all cards that we have, where Mastercard wins by 52.2% of total market share. Then we have Visa, which is having only 37.8% market share. We have MX having 6.5%, and so as for Discover having the lowest 3.4% of total market share. After that, we are going to do the same thing for different card types. We want to check out the pie chart for that as well. Over here, debit card is having the highest number of market share, that is around 57.1%. Credit cards are only 33.5%, whereas debit prepaid cards are only 10%. So now let's talk about the next thing, which is histogram of credit limit. Here comes the interesting part. Now we are going to see the distribution of credit limit. Now, we have converted our credit limit to a numeric value, so we won't get any errors in this case. Over here, we are using the histogram to see the distribution of our credit limit, and we are going to set the credit limits into the format of a list, as you can see over here, and then we have this whole code structure which you can easily understand. After that, we can see in the distribution of credit limits over here the number of users. For almost 3,700 users or more than 3,500 users, the credit limit is between 0 to $20,000. And after that, we can see a sudden declination in the credit limit, where the number of users are only around 1,800 to have a credit limit between 20,000 to somewhat around 30,000. And then only 400 users having their credit limit around, I would say, more than 30,000. And then very few users, I would say, or not users, number of cards, I would say, having their credit limit around 80,000 or around over 1 lakh. Okay, so over 1 lakh, I believe there will be only a single digit cards having their credit limit around it. Okay, so that's a pretty good analysis over here, and we can also see that this graph is right skewed. There are more values towards the right, and then you can see the tail that is going to zero when it goes or when it falls towards the left. Okay, so again, it's a very good analysis. We have box plot to see the effect of credit limit per card type. Okay, so now basis on your card type, does the credit limit changes? Well, let's try to see with a box plot. Over here we have three card types. We can see debit prepaid will have no credit limit because it's a prepaid card. For debit card, although, we have the credit limit between maximum between the range of 0 to 40,000, and then there are a lot of outliers going up to 1,40,000 and more than that as well. There are two outliers, means there are two cards having their credit limit more than 1,40,000. Okay, similarly for credit cards, we have the limit from 0 to somewhat around $30,000, and then there are some outliers going up to 1 lakh US dollars. Okay, so after that, so from this analysis, we can clearly say that debit cards are having more credit limits than credit or debit prepaid card. Well, debit prepaid card is not a variable of our interest in this case because it's going to be zero. After that, we'll check for the box plot of credit limits per card brand. So till now we saw for card type. Now let's check for the card brand. Which card brand offers the maximum credit limit? So over here we have Discover cards, and it is ranging from 0 to somewhat around 25,000. For Visa, it ranges from somewhat 0 to 40,000. For MasterCard, it ranges from 0 to somewhat around again 40,000. And there are some outliers in the case of Visa and MasterCard, but MasterCard wins over here, having two outliers more than 1,400. That means $1,40,000. And these two outliers are probably of which type? Well, if you look over here, you can clearly see it is of debit type. Okay, that means these two outliers are having a card of MasterCard, card brand of MasterCard, and the type is debit. And then in the case of MX, we are having one outlier having a credit limit around 80 or 90,000, and rest of all are between 0 to 25, and then some outliers after that. Okay, so again, this is a pretty good analysis. And after this, both graph, what we have analyzed till now, although this is not a true effect, there can be some co-founding factors over here that might show this relation that you see right now. Okay, and we'll check about all those things in our next video. For now, just for the sake of simplicity and only analyzing the graph, if I look at these two graph, I can say if someone is having a card of MasterCard and the type is debit card, they are going to probably have a higher credit limit than any other card type or brand that they get. Okay, and now let's talk about the histograms for number of card issued. So number of card issued means for the same card that you have, you can get a new card. There are two conditions for that. Number one, your card is expired, so you will get a new card. Number two, your card is stolen, so you get a new card. I hope you understand. So this distribution shows that almost everyone, around 3,000 people, have one card, or they got just one card in their entire life, or the card was only printed one time. Then there are around 30,000 only, slightly lesser than that, let's say 2,900 cards which were printed two times or distributed second time as well. Either they were expired or they were simply stolen. And very few cards, around 100, were given or distributed for three times, which is again a great analysis. Now let's talk about time series analysis for account opening dates. Well, over here we can see that the trend shows the years and the number of accounts open to that year. Okay, so since our account open date is in year format, so I'm going to take out the year from this, and then I'm going to count the number of accounts that were open. I'm simply going to just count and sum up that into the variable num counts. Okay, num accounts. So this will count the number of accounts that were open in a particular year, and after just putting it into the format of a list, I'm gonna show this or plot this into the graph. And over here I'm going to say dot plot to get a time series analysis graph. Okay, so over this graph you can see gradually it is increasing till 2008, and then in 2008 something happened. I don't know what, you tell me in the comments. And then the number of accounts that were opening were decreasing till the next 10 years. That means after the financial crisis that we saw in 2008, people were not tending to open new accounts. So they just simply didn't do that. But something again happened around 2019 that people started opening new accounts. I don't know what happened in 2019. You tell me in the comment section that what can be the reason that why there is a sudden increase in the number of accounts opened in 2020, why it's around 1200, and why there was a decrease over here. Was that only because of the financial crisis that we faced, or there was some other reason? Okay, so again, this is a very good graph. And now let's talk about time series analysis versus pin changed. So we can see the pin changed, and according to the year. So which year, how many number of pins were changed? So in 2002, there were no pin changed. In 2003, there were slightly, somewhat pins were changed for some cards. And then this graph goes on and on and on and on. Okay, so simply try to analyze this by your side, and you give me the hypothesis or the conclusion that you get after looking at this graph in the comments. After that, before we further talk about this, let's take a small 1 second break. So now comes the number of card issued per year. Okay. So what we want to do is we want to check. Now to check it, we are going to use a bar plot to see the number of card issued uh, per year. Okay. So we can see the maximum number of cards were issued in 2020, and this graph is also similar to what I have seen before over here in this case. Okay. For the account opening dates, or I would say account opening year. Okay, so again, this is easy to understand that there were more cards issued in the year where there were more accounts opened compared to the years where there were less account open. Okay, so after that we have the scatter plot to understand the account opening date versus credit limit. So does credit limit matter for the account opening dates? So for that we have a dot scatter function to make a scatter plot, and we can see that if the account opening date is 1990, then the credit limit is higher, but at the same time it is lower as well. And in general, this is not showing any sort of like dependency, any sort of a relation that can be either a positive relation or a negative relation. This graph is pretty much a standard graph scattered normally over the values, and there are no such relations that I can see in this graph. Okay, so I think that looking at this graph, there is no relation between account opening year and the credit limit of that particular account. Okay, after that we have stacked bar chart for credit card expiry trends by year. Okay, so we'll look at the card expiry, and we can see that over here more cards were expired in 2020, and then there is a number of cards that are expired. You can see for the 2021 it's around 900. For 2019, although it's very less, that means the limit of card expired was somewhat around 10 years. So for the first 10 years or 20 years, there were really less cards expired. And even if there's some cards that were expiring, those were the cards that were issued in the year 1919 or 2000s, early 2000s. Okay, like 2002 or 2003. So those were expired around these dates. And then after a certain amount of time, that is 2019, there was a sudden increase in the expiry dates of the cards. Okay, and yeah, you can basically look at this and give me your conclusion to this graph as well in the comments. After that, we have count of cards with and without chip. So again, you can look over here. We are creating two lists, with or without chips, and then we are just putting it over here as a histogram. More people are having cards with chip, and less people are having cards without chip. Now you can also check that the people having cards without chip, when their account was open, in order to check that if the users are having card without chips are having their account opened before, let's say, 2005, because at that time this technology was not available. So this is up to you how you analyze the data. For now we'll keep it simple. And now let's talk about the numerical analysis. Number one thing is dot describe in order to check the general description about our data set: mean, median, first 25% value, 75% values, and the maximum values, minimum values, things like that. So let's take, um, suppose we have credit limit. So in total we have 6146 values, and there are no null values over here. We can see the mean over here for the credit limit is going to be 14,374. That means this is the mean credit limit for the overall data set. Then we have the standard deviation. It says that there is a 12,114 dollars of standard deviation, means the data is spread really well. There is a big spread in our data set. Minimum values is 0, you can see. And then first 25% values are 7,030 dollars. That means 25% of users out of all the cards that we have falls under the credit limit of 7,030. Then 50% of our cards are having credit limit less than 12,594, and then 75% of our cards are having their limit below 19,158, and the maximum card limit is 1,51,223. Okay, so like that you can check it out by yourself. And this describe is only used for numerical values. That's why for card brand and client id and for all other variables like this, it is of no use. Okay, so check it out by your side as well, and try to understand the different effects or statistic of our column. Okay, a numeric column. So now we'll try to understand the correlation over here between credit limit, number of card issued, and account opening date. Okay, so here we got a correlation matrix, and between credit limit and number of card issued, there is a weak negative relation which is almost negligible because it's 0.08. If it is somewhat around zero point 0.1, then also it's fine, but it's zero point 0, so it's almost negligible. And this is same for all other case. You can see for account opening date as well. For account opening date versus credit limit, it is positive but still almost negligible because it's 0.0818. Okay, not even 81, it's 18, which is again a very weak correlation. Similarly, for the account opening date versus number of card issued, it's a negative correlation, which is again almost negligible. So that concludes that there is no relation between credit limit, number of card issued, and account opening date. After that, we can analyze the credit limit analysis per card brand, and it shows that the average credit limit for MX card is 11,000. For Mastercard, it's 14,000. For Visa card, it's 14,000, and for Discover, it's only 10,000, which was something that we saw previously as well. So again, this is how we try to analyze using numeric values. Now let's see. So similar to checking for the average credit limit for different card brands, we can do it for card type as well. And it's pretty simple. You can see over here the logic of the code that we have used, and we use dot mean function to get the mean value. And we can see that for the debit prepaid card, the limit is pretty low. It's around $64 only, and we'll see why that's the case in our further video. For now, it's just 64, although it should be 0, but it's 64. That means some cards are having low credit limits over here as well. Okay, then there is credit limit for credit cards is around 11,174, but for the debit card it's the highest, which is around 18,557. Okay, and then there is a point as well which you can take under consideration if you want. Okay, so that's the case for our card types and credit limit per card. Okay, so average credit limit for per card type. Now we talk about the percentage of cards with chip and without chip. So course percentage of card without chip is only 10.51 percentage. Okay. Again, a normal analysis that you can do. I just want to show you what is the power that you have with numerical analysis. Over here you can see also it's pretty simple. We have this variable. We are going to filter it with the values of has no chips, and then we are going to get the height of it, and then we say that total cards equal to df cards dot height, and the percentage of non-chip is equals to the non-chip cards, which is over here up divided by total cards, which is going to be the complete height of our the total values of our data set, which is 6,000 or something like that. Okay, so you can check it by df.head, or yeah, by df.describe you can get the total number of values in our data set. Okay, df.describe is the way to do that. But for now, what I'm going to do is I'm going to just run this code, and you can see I'm getting 10 over here. Okay, I guess my code is not executed. That's why I'm getting this error. So by doing the run all my code cells will be executed one by one, and this error will be gone. So just hold for a second, and you will see that the error is gone. Okay, it's 10.1551. After that, we are going to check for the client level analysis to understand average number of cards per client. So average number of cards per client is 3. That means there are a lot of people having more than 3 cards. Okay. Then we'll talk about the oldest and newest card. So the oldest card is from the date 1/1/1991, and the newest card is of the date 2/1/2020. Okay, so that is it for this video. I hope you understood the basic analysis. Although it was not something great, you can see we just have took this dfcards.min to get the minimum value of the date and dot max to get the maximum value, and then we are simply just printing it out over here. So this is the basic analysis. Although to understand the true effects of different variables, we have to perform some test statistics like chi-square test, ANOVA test, in order to understand the relationships of categorical variables with other categorical variables as well as numerical variables. After doing this analysis, we'll figure out what is the relationships between these cards and the users. Okay, so in our next video, we are going to combine these two tables. As I've told you in the starting of this session, in this file user.dataset, we have this id as our primary key, which is working as a reference key or as a foreign key in our cards dataset. Over here it is written as client id. So on these values I can do combine, or I can apply a join, which is known as combining two tables on this condition, which is client ID and ID in my user dataset. Okay, so by these two columns, I'm going to combine these tables, and then further I will start my analysis. But in the next video, we'll perform the uh, good analysis where we'll talk about statistics and about p-values and other things like that. So next video will be pretty interesting for you guys, and after that we might make a Power BI project around it, or we do something else which is much better, and eventually we'll start adding new concepts of AI to this thing. I'm thinking also to add a AI powered BI project around this using Snowflake, although that's a part for the future. For now, that is it for this video. I hope you really understood and enjoyed working with polars, and maybe I will continue with polars for the rest of this series, or I will use pandas. But pandas is much slower than polars. In fact, polars is around 5 times faster than pandas, and that's why we are using it. So, yeah, that's it for this video. Have a nice day. Take care.